Remember everyone to use the hashtag FOSSAsia or FOSSAsia 2017. Make sure we get lots of likes and retweets on that back to the FOSSAsia event. Next up, we have Mike. Your full name is?
Qin Fengling. Qin Fengling, yeah.
Okay, you can also call him Mike, I was told. He's going to be speaking about software security on his hardware, specifically for the AvalonMiner. So, without further ado, thank you.
Thank you. Yeah. Good afternoon, everyone. Yeah. Thank you. Yeah. I will give you a talk about the blockchain software for the hardware. I think maybe it's so big for to talk about the hardware because a lot of Bitcoin hardware, is different. We chose open source solution for the hardware. I think it's not only for our miner, it's also for every embedded system, I think. So we will talk about the solution, the Canaan AvalonMiner open source embedded system. So I will first introduce about me and my company. First, sorry. About me, Qin Fengling, because it's a Chinese name, so it's hard to pronounce maybe in some Western countries. So Mike, maybe for short. You can find me through Twitter or GitHub, with this name. Later, I live in Beijing for 10 years, working on open source project now, on open source software and hardware. And also, I like Linux program. I have a lot of experience in embedded software through the set-top box and then the IoT gateway. So it lacks the. I always use some software from the open source community. So then in 2014, I joined the blockchain company Canaan. So I start to learn like a total embedded solution in the embedded hardware. It's from the OpenWrt, it's an embedded Linux system, and Lucy, a web framework, is used for embedded, if someone knows. And a converter is a protocol converter for the hardware to convert the USB protocol to a I2C device. And the is FPGA hardware, And I started developing the firmware from Avalon 3. This is Canaan. Canaan is maybe it's a new name for everyone. If someone knows the AvalonMiner, maybe Avalon, they may know, because this is the same. The guys from Avalon then create this brand, So we have done a lot of products before create this company. So I will talk about some of this. Maybe we'll clear about this. So if someone search the miner through the network, maybe find this. A lot of stuff. It's called Icarus. It's the very, very beginning FPGA Bitcoin miner. It's open hardware in GitHub, so everyone can find this through GitHub. If someone want to, I think if someone want to learn the Bitcoin how it worked, this is a good solution to start. But it's just FPGA based. It's not fast. I think there are few devices used these days, but it's very, I think it's great. It's very great. Another Lancelot is, how to say, is super fast than the previous, and also is FPGA based. These people from Canaan found it's very hard to make a very fast device if they use FPGA. So they try to make ASICs. So later we made the first ASICs, Avalon 1. It's not beautiful today, but it's the first generation we made ASICs, and then we made products through ASICs. So the next, we also make a new generation, the second generation, like this. Seems a little beautiful than previous. But also, yeah, we need change because a lot of competition and a lot of products. And not later, a new ASICs we made, and then like the same hardware. So you say a lot of hardware. So just everyone do not know what it is, or how does it works, or what it works for what. So it's just for proof it works. Next, so we try this. This is simple, and this is very, very simple for portable. So we have chance to let maybe some hobby and some research to know how to start use these small devices, and it's also very cheaper. Yeah. Later, bigger machine. Yeah, use a new generation, the 4th generation ASICs. I think I will quick look at this because it just we made. And this is the same generation with this, but maybe pretty for portable. Another is we also want to improve the user experience because maybe it's hard to use, because if someone mining before, they just clone the CD miner and compile. It's hard to use. So we create this. It's a device, it's HID device, so it can use on Linux, Windows, and OS 10. So we made this. Today we only have 20 devices here. So if anyone follow the Canaan Twitter, first follow, first guide. Yeah, only 20. Yeah, this is a 6th generation. It's super powerful, and it's a stable products we made, I think. And it's still used in somewhere, maybe in American, Europe, and China, and a lot of places. What? Uh-oh. Okay. This is the latest product we made. It's a super fast device we've made in these days. So it's also the latest ASICs chips we've used. So totally I will say how can we build a software for this device, because you can see this table. Maybe we will release 1 or 2 products every year. So if we can't find a solution to support all these devices, because the ASIC is different, so we must find a way to fix this. This is from Icarus to the latest. So we found a way to use the protocol, only 2 main protocols we use, Icarus and MM. Icarus is public, and also MM is also public. We'll talk about first because it's used for the latest miners, for the fast miners. If we use the miners like this, the Nano, it will use the Equus. So it's only used for slow miners, but it's very helpful to learn how the miner works. It's easy protocol. So I will show a connection to describe how this works, how the machine works. In the left side is a controller. Maybe cannot see clearly. It's controller. I will show this controller. It's called AvalonMiner controller. So it will control all the miners. And then it's the converter. This is converter. It's a microprocessor we use to convert USB to SQRC. Yeah. And then connect all the devices through the chain. So this is in the miner. This is a SQRC slave device. If someone knows, yeah, it's a SQRC. We can support 5 miners max on one chain. If you want to support more devices, more miners, just connect more AUC converter. It's enough. It's easy. So one controller maybe can control 60 miners. Yeah, it's super powerful. Yeah. So maybe you can use to other products. I will talk about the firmware run on every device, like the controller, the AUC3, and in the miner. It's different, but the first is the controller. So this is a simple architecture for the software. So we base the OpenWrt. Does anyone know this? Oh, please. Okay. So seems a few people. So I just to talk about little about this, brief about this. It's embedded Linux release for like router. It's mainly use this. So it can support a lot of hardware. You just like if you want to use more or custom your functions on the router, like you want to build your self firmware for the router, maybe you find this or some DDWRT like that. Then we use this, so it has package system. We do not need too much about this. So just create 2 packages for our miner. We use CD miner to control all the miners, and this is for upgrade the miner's firmware. And the top is a web framework. So users will use a simple web interface to control all the devices, all the miners. This is a very important part in the system. It's also open source. What we do, just add some drivers here. It will support all different manners. Yeah, it's very easy. Then later, this is a web interface. This is the configuration. It's very easy. Just fill this and then apply. You will manage the manner. The manner status will here, and also some important for the manner. So this is the like the AvalonMiner controller. So next I will talk about the AUC. Why we use this device? Maybe someone knows there are few devices with I2C. So we use a converter to convert the USB to I2C. So that's it. Why we use USB or not? why we use USB in the miner? Because it's very, you need a lot of work to do in the software. So just the I2C is enough for the miner. So just the I2C slave. This means the miner, and this is a converter. So we wrote a firmware for the converter. It's based open source framework here. So you can use the device, I think, if someone want to program some I2C flash or I2C devices can use this device. They do not just use in the miner. So you can also change the firmware to other, like SPI and also other. So this is also open source. I also think you do not need to pay the SDK for this. Later I will show how to compile the firmware for it. And this is important and very important thing in the miner. In that board, in the big chip, it's a Linux, it's FPGA. So this is architecture. We use C program language in the device, so we need something to do. Like we add a CPU. This is CPU. Like yes, this CPU, and this hardware just communicate through this wishbone bars. If someone know, FPGA is open bars. Yeah, it's open bars for the open cores. So you can see a lot of this, and this two part is for miner. If someone just want to use this to to convert some protocol and do something like programmer, you can use this part for free because it's also open source. And this is the SHA 256 core. It's only used to generate the task for the miner. And this is a communicator interface only for the specific ASICs. So this is the special one, and this is the common. So everyone can use it. Maybe if you want to use at a hardware accelerator, it's good. It's also good. So it's a full function hardware core. Yeah, this is MM. I think MM we made it. It's a full name is called Miner Manager. It's used for generate tasks. So do you think someone think it will be enough to generate the task in the controller in this way, in this side? But the software is not very fast. They just need to know what's the result. So we can use a very cheap controller to control the super powerful manner. So we use the hardware to generate the task for miners. It's only support the three-term protocol if someone knows. So it's usually used in Bitcoin if you use MM. I say if you use this, if you want to change to altcoin, maybe you just change this hardware is enough. Then yeah, I just quickly talk about this. This is about how to generate for the controller and AUC and the MM. So first is open directory based. Just clone the source, add the face from Canaan. And if someone want to maybe clone and add your own face. Yeah, choose the target and compile. Yeah, it's all. This is controller. We also add some automatically way to support the devices. We use the build script to support a lot of hardware. So just use these tools and build for the device. And if someone do not know, just use a daily build. And also we have a build board. Is everyone use build board? It's OpenWrt CI system. Let's see here. I will show. Yeah, it is. You can see the status of the building. So if someone want to know how the firmware is built for different device, just click every shell here is okay. So we build it for Raspberry Pi and on controller. Yeah, so it's super easy to find the status. Then next is AUC. Because we use a chip from NXP, so we must install the SDK first and clone the source and then build it. The next is MM. Because the MM is a selling device, so we must install the ASIC and like this. So more details here. I just list all the repo we used, so it's easy to find for every miner and controller and like CG miner. This is the MM protocol, and this is Icarus. It's a slow miner. Then we talk about the contribute. We try everything in the open source way, so we want to keep everything we made to upstream. So this is what we contribute to the community. This is a CG miner. You can say it's not clear. We are top 3 contributors to the CG miner. It means we are we have the biggest contributor except the 2 creator, the author of the CG miner. And OpenWrt, we also try to synchronize with the latest. So a lot of contribute. And we support all of this device default if you use a build script. Also, if you have another hardware, it supports OpenWrt, then you can change little in the build script. It can support. And we also wrote some documents in Wiki, Bitcoin Wiki and OpenWrt, and also Wikipedia.
So if it's okay, why don't we open it up for some questions?
Okay.
Okay, anyone have any questions for Mike? Yep.
Can you click through really quick the rest of your slides?
Okay, no problem. So this is for Canaan. How to contribute to Canaan. This is an easy way. Just clone, fork, and pull request. How to start? You can read documents through Wiki form and talk through the IRC. And the book is mastering the Bitcoin. So the last is demo. Easy. I will show you how to use Chrome to control this device, the small miner. Here we'll use Chrome. So in the apps, web store, here search Here, just add to the. Just add this. So this is miner. And also, we try this. Here, when you open, it will show this because you need to plug your device. Just plug to the USB adapter. Here, easy. The enter. If this status so active, it will mining. Will say, this is the hash rate chart, and this is the status. This is temperature device, and this is the hash rate. So it's super simple. You can also use command line to control this device, like CG miner, like BFT miner. So just follow Canaan. You will get the free nano. So any questions?
Great. Any other questions?
Anything about the hardware, maybe OpenWRT and some converter. Yeah.
Okay, great. Then why don't we wrap it up? Thank you very much, Mike.
Okay, thank you.
Thank you.
Hi, the miners are right here. If you followed, come up here, show that you followed, and we give you one, okay? Right there. Great. Round of applause for Mike. Yeah.